Hello, in this video I'm going to talk through the statistics cheat sheet that was developed based on a question asked during a live class meeting where the students helped me develop this kind of cheat sheet, so to speak, for the different statistical tests used in our class. Includes the key terms, difference, relationship, prediction, and those are key terms both to help you kind of understand the difference, as well as the key terms in terms of what word you should use when you're doing the hypothesis for those tests. The type of test, type of variables needed for a specific test, and example variables for that test. So the first one is differences. Anytime you're talking about the differences, you're going to be talking about either an independent samples t-test, an ANOVA, or a MANOVA, because the whole purpose of these three tests is looking to see, is there a difference between the categorical variable based on the numeric variable, or in MANOVA, variables. So for an independent samples t-test, you do have one categorical variable with two groups. So for example, men and women, and then you have one numeric variable. So for example, TV watching, in terms of the number of hours per week someone watches TV. So for this independent samples t-test, you're looking at the difference between men and women and how much TV they watch. So your null hypothesis would be that there is no difference, and your alternative would be that there is a difference. Now for the ANOVA, it is also one categorical variable and one numeric variable. But with the ANOVA, the difference is that for the categorical variable, you're comparing the difference between three or more groups. So for example, men, women, or other. Now you still only have that one numeric variable, TV watching. The only difference between that ANOVA and the independent samples t-test is that you're adding an extra categorical or an extra group to your categorical variable. So the ANOVA hypothesis would be very similar to that independent samples t-test, and that you're looking for the difference. Just this time you're looking for the difference between men, women, and other, and their TV watching. So you're trying to see, is there a difference in the amount of TV watching, so that numeric variable, based on gender, men, women, or other. Now for the MANOVA, it is also trying to tell if there is a difference. You do normally have three or more groups. You can occasionally get away with two or more groups or two groups, but in general, you really are looking for three or more groups. So once again, we've got our three groups, men, women, other, and we've got this time two or more numeric variables. So TV watching and exercise, where exercise is the number of hours per week someone exercises. So the difference, the main one between ANOVA and MANOVA, is you still have the same categorical variable, but that difference is you have two or more numeric variables, where here you just have one numeric variable. So with the MANOVA, you are still looking for the difference between these three groups. It's just you're looking for the difference between these three groups for both numeric variables. So you want to know, is there a difference in TV watching and exercise based on gender, meaning men, women, and other. So similar though to both of these two hypotheses, MANOVA is just the null is that there is no difference, and the alternative is that there is a difference. So that is differences, the independent samples t-test, the ANOVA, and the MANOVA. Now for relationship, the relationship is all about the chi-square. So for the chi-square, we're looking at two categorical variables, and you're looking for the relationship between those two variables. The number of groups doesn't matter, you just need two categorical variables. So for example, gender and political party. So gender, you could have two groups, men and women. Political party, you could have Democrat, Republican, and it would be fine. You could have gender, male, female, other. Political party, Democrat, Republican, liberal, independent. It doesn't matter how many different, categories or groups are within each categorical variable. You just need two categorical variables. So if you have two categorical variables, that would be a chi-square. Your null hypothesis would be that there's no relationship, and your alternative would be that there is a relationship. Then we get to the Spearman correlation. So for this one, I just want to note it could be thought of as a relationship or a difference. So either one works. So when you're doing your hypothesis, it doesn't really matter if you say there is no relationship or there is no difference. Either one really can work. But the key thing to look for, so this is the key thing to look for example, when you're taking your quiz, is that it will clearly state in the quiz that the data is non-parametric and ranked. And that's really important. So in order to do a Spearman correlation, it is a non-parametric test and it is ranked. So that's the big difference between the Spearman correlation and just the regular correlation / Pearson correlation, is that the Spearman correlation is non-parametric ranked data, where the regular just Pearson correlation is just two numeric variables. In both cases, you can refer to them as a relationship, but for that relationship, note that for the Spearman, you could also talk about it in terms of a difference. It can go back and forth. But for that Spearman correlation, you do have two ordinal ranked variables. So for example, maybe customer satisfaction ratings and Likert scale question. So those are ordinal or ranked data that could easily be used for a Spearman correlation. So like I said, customer satisfaction rating, like how much did you like your chicken sandwich, 1 through 5? A Likert scale question, how likely, so how much did you like your chicken sandwich, 1 through 5? How likely are you to go back to this restaurant, 1 through 10? But that is ranked / ordinal data. You could also do it in terms of the ranking of what rank are you in class, what order did you come in, how in order in terms of who submitted an assignment first. That could be an order. So those are all things that you could do a Spearman correlation on. But the big thing is that if you're taking a quiz or a test, it's going to be non-parametric ranked data. So then we go to the regular, just plain old correlation. This is a Pearson correlation. And for this one, you do need two numeric variables. So for example, TV watching and exercise. But you do need those numeric variables. You can't do this with any categorical data. And once again, for that hypothesis, your null is going to be that there is no relationship, and your alternative hypothesis will be that there is a relationship. So that is the chi-square Spearman correlation and the Pearson / regular correlation. And then that leads us to prediction. So correlation kind of does lead directly into the linear regression and the multiple regression. In fact, I've said, multiple regression is kind of the big brother or big sister for linear regression and correlation. But the big thing is that there is a difference in the hypothesis. For a correlation, you're looking at the relationship. That is it, just that relationship. For a linear regression and a multiple linear regression, it is all about prediction. And that is mission critical. That when you think prediction, linear regression, multiple linear regression. A linear regression is not looking at the relationship, it's looking at the prediction. Can one variable predict the other variable? Same thing for multiple linear regression. You want to know if, these two variables can help predict this variable. So for that linear regression, we've got one independent variable, for example, and this independent is a numeric variable. So it's one independent numeric variable. And that is important for just plain regular linear and multiple linear regressions. You are working with numeric variables. I will say that you can use some categorical, but in general, we're just going to deal in most cases with numeric variables, because once you start working with categorical, you have to start dummy coding and doing all sorts of crazy shenanigans to make it work right. And that's just, we don't have enough time in our class to go that deep into it. So for the sake of our class, a multiple linear regression is done with two or more numeric independent variables. So for example, TV watching and optimism, and one numeric variable, exercise. Where that linear regression, you've got one independent numeric variable, TV watching, and one dependent numeric variable, exercise. So in this case, you want to know, can the amount of TV someone watches helps predict how much they exercise? For the multiple linear regression, you're wanting to know if the amount of TV and their level of optimism. So think of optimism as an optimism score, like 1 through 30. How optimistic are you? So these are both numeric variables, and you want to know, can TV watching and someone's optimism level predict how much they exercise? So linear regression, just two numeric variables. It's very similar to that correlation. The only difference for the correlation, you're looking at the relationship. For the linear regression, you're looking at a prediction. And then for the multiple regression, you're going to have 3 or more numeric variables, and that would be 2 independent variables, so 2 predictors that you think can help predict that one dependent response variable. So I hope this helps. If you have any questions, let me know, and have a great day.